Hello and welcome to a new edition of CryptoKoryo podcast. In last episodes, we've talked about the risk-taking narrative as well as the AI narrative. Now, in this episode, for the first time, we are talking about account abstraction, one of also the big themes of recent years. So I'm happy to have Ethan Francis from Particle Network here with me today. Hi, Ethan. How are you doing?
Good morning. Good morning. I am doing great. Excited to be here. I've watched a few of the other episodes in the series that you've been doing, and I love them. I'm pumped to kind of dive into the conversation today. There's a lot of really cool angles and kind of surface area to cover here, especially in regards to account abstraction and interoperability, kind of like the future of UX. So, yeah, I think this will be a dope conversation.
Amazing. Looking forward to your insights. So, we always like to start with an introduction about your background, how you came to DeFi, crypto, and what led you to Particle Network in your case.
Sure. Yeah. I've been in the Web3 space now for, I guess, probably around 4 years in total. It doesn't feel like it's been that long, but I think in the Web3 space, usually 4 years is a decent length of time. Originally, I got started in Web3 when I was around 15, and I started kind of like getting into things, building different applications, kind of learning the development side of things. Eventually, I kind of launched my first application back in 2020, late 2020, really early 2021. That did decently well. It was kind of like a small app that I made and got some decent amount of users from there. Eventually, once I turned 16, I started working in developer relations. I kind of got into that space and started at an RPC provider for quite a while, and I worked there for about a year and a half. Then, I guess about 7 or 8 months ago, back in September, I joined Particle, and it's been awesome. The big reason I joined Particle was because for a while, like I mentioned, I worked doing developer relations at an RPC provider, and I've been kind of exposed to a lot of different parts of Web3 in terms of technology, especially as it relates to developer trends and things that are affecting builders, right? So, like whenever I had the opportunity to join Particle, really the thing that drew me in was this, and I'm sure we'll kind of talk about it more, but kind of like this like cutting edge UX and like this idea that like Web3 today is not where it's at, not where it needs to be to actually onboard significant numbers of people. Like there's a lot of really great things being built in Web3. I mean, amazing applications, amazing pieces of infrastructure, incredible feats of engineering, but one of the core issues and like one of the main blockers today of like why Web3, why as like all this money that we've been investing in Web3 hasn't materialized on the consumer side. There's like core reasons for this, and there's like things that you can point to on the user experience and like issues that you can kind of outline that need to be solved, and they haven't been solved yet. So I really wanted to be a part of that and kind of have the opportunity to contribute to the solution of issues that could ultimately lead to the space being adopted en masse by consumers, and these applications being kind of like going mainstream. So I really want to see that personally. And I think at Particle, we've been doing a lot to kind of get us closer to being able to have that type of ecosystem. So my big motivation for joining Particle back in September was exactly that: was to make sure that we have that kind of a type of ecosystem, and that I can contribute where I can on the developer relations side, on supporting developers, integrating solutions that they can kind of make their own applications user friendly and whatnot. And so far, it's been awesome. I've been loving it. And of course, now we're like getting into some pretty insane solutions that I personally believe are going to change the course of the industry, especially when it comes to the capacity for users to be onboarded and retained, for new users to get into the space, and so on. Which we'll kind of talk about the specifics later. But yeah, it's been awesome, and I'm pretty pumped about what we're building here at Particle.
Amazing. So, Particle is actually doing a lot of different stuff, which is on a lot of different topics. So, there is account abstraction is one of them. There is interoperability. There is modularity and rollups. There is, you know, cross chains and all this kind of stuff. So, there is a lot of things to cover. There is data availability, but I think and one of the core elements of Particle has been account abstraction element. Um, so let's talk about a bit account abstraction in general before delving into particle in particular. What is the state of abstraction today in 2024? Vitalik has spoke a lot in recent 2 years in conferences, working actively with projects. There are a lot of projects working on this account abstraction problem, Argent and others. There are different ERC standards like 29, 38, 43, 37. And we've heard some of some hot words like social recovery, smart wallets, bundling transactions, gasless transactions, multi-sig, etc. Can you just give us an overview of where we are coming from in terms of account abstraction, where we are, what are the current challenges, what are you guys and other projects in this sector working on?
For sure, yeah. So, I think it's always important to kind of contextualize where we're at with account abstraction, and that like ERC 437 was really only kind of like deployed. I think at this point it was only a little bit over a year ago. So we're still very early in the days of account abstraction, especially in regards to like having mature tooling, having a lot of adoption in this regard. But actually, I did a talk at East Denver. The title of the talk was something like slow start to fast adoption of ERC 437, and the point of the talk was basically like, why has ERC 437 not been adopted? Because unfortunately, it hasn't been adopted to the degree that some people might have expected it to have been, especially given the implications that it has on user experience. Because of course, like at the center of account abstraction of specifically ERC 437, we're migrating users from what is an extremely rigid account structure, externally owned accounts, EOAs. This is what you use within a mask and whatnot. We're taking them to basically like an infinitely flexible account structure that developers can use to really fine tune the user experience to a very intense degree. Gases transactions are huge. Pop-up list transactions are big. I mean, the list goes on of like benefits, like an abstraction, objective benefits that applications can take advantage of to create things that weren't possible before. But you have all like this laundry list of benefits, then why hasn't account abstraction really been adopted to the degree that we want it to be? Some numbers, I believe, like the top five blockchains, it's like Avalanche, Optimism, Ethereum, Polygon, and maybe it's Arbitrum. I think collectively they have like it's something like 10 million user operations, 10 million AA transactions, which is pretty low. I think a particle we've done about 6 million, 7 million at this point, just across different kind of like not the top five chains, but other external chains like Linea and OPBNB and Combo and stuff like that. So like just it's clear that not a lot of applications are using these for like high volumes of transactions, and there's a lot of reasons why. I mean, you can point out like there's some optimization issues. Users have to pay gas fees for deployments whenever they start using a smart account across a different chain. There's a lot of multi-chain issues with like keeping a constant smart account state. Sometimes account abstraction can be a little bit more expensive if you aren't using batch transactions, and the list goes on of like some inefficiencies and things that can be solved. But I think ultimately one of the big things and one of the big reasons of like why account abstraction is where it's at today in terms of not being like the leader of the mainstream narratives yet, at least, is because developers haven't really had a major reason to use account abstraction up to this point. I mean, the benefits are great, but when developer tooling with account abstraction has been pretty difficult to use for a long time. Like, I mean, before really just over the past 4 or 5 months, using account abstraction like programmatically within your application was pretty difficult. It required like as a developer you to really dive into these concepts and understand them to a significant degree. Whereas like today, it's very easy to use account abstraction as a developer. You don't really need to know what's happening, and there's SDKs, including our SDK, StackUp, ZeroDev, that make it incredibly easy to use it. But still, even with that, the incentives for developers to integrate account abstraction have been somewhat lacking in terms of the total benefits that they'll get from the integration. So, like, they'll have social logins sometimes kind of tied pretty closely with account abstraction, gases transactions, session keys, and so on. But what this means is that like still this isn't enough for developers to like feel satisfied or feel like it's worth going through the engineering effort to integrate account abstraction. So what we believe is that account abstraction will actually be used, like specifically ERC 437 or any other standards that come after it. We believe that account abstraction will be used as sort of an infrastructural foundation. So like the core of account abstraction as it is today might not be the 100% driver for all of our problems being solved in Web3, but it'll act as a foundation for more specific and targeted solutions to be built on top of it that leverage account abstraction as that foundational kind of infrastructural component that allows it to exist in the first place. A good point of this, and we'll kind of get into it later, is at Particle we're building these things called universal accounts. We can talk more about the specifics, but basically, like this is an interoperability solution. So, like these kind of like branching off of account abstraction and solving really targeted issues that still require the utilization of account abstraction. This is where I think that we'll see a lot more adoption of account abstraction, because developers they'll look at something, they'll say, well, I have this one issue where like I'm having a hard time onboarding users because I've deployed on a rollup or some sort of app chain or something, and getting people to bridge over, like it's an extra step and stuff like that. So like all of a sudden they have the solution where that doesn't need to happen anymore, and users have like instant access to the application through the means of account abstraction, or a few other kind of like cool solutions that you can think of that would be built on top of AA. These are things that are going to drive full adoption, right? Once we can kind of like target different parts of the UX issue in Web3 through the means of account abstraction, using account abstraction as a vessel for this, that's when I think we'll see this number of user operations, this number of smart accounts that are created every day go up exponentially, because now developers have real incentive. They have real problems that are being solved beyond just kind of like these generalized improvements. So this is like, kind of to recap all this, at the moment, account abstraction is still very new. It hasn't been adopted to an insane degree. It definitely has had some level of adoption. Developer tooling is getting a lot better. And now, as we start to get into a more mature, like slightly mature phase of account abstraction, really what's going to be driving adoption, at least from my standpoint and kind of what we're betting on at Particle, is that these solutions are going to be built on top of AA, the kind of more extraneous solutions that are solving more targeted issues. These are really going to be the big drivers of adoption in this case of account abstraction. So hopefully that gives a decent image of kind of where we're at and the path that we'll see to have mass adoption of AA.
Great. So what I'm understanding from what you're saying is that basically we have the technology, like we have the solutions for account abstraction, bundling, gas-based transactions, but we have a problem with here the devs that are not really using these solutions yet. Is that correct? Like, can you confirm that we have actually what we want to do with account abstraction, etc., but it's just a matter of adoption from devs?
Yeah, with like the foundation of account abstraction, like purely AA, like in standalone. So like smart accounts and the SDKs associated with that, and now we even have like modular smart accounts with like ERC 6900. I mean, like the tooling is there. Like I think for a long time it necessarily wasn't, but today we have really strong AA tooling, and it's only getting better. So it definitely isn't super difficult to use AA. The issue is just that like we haven't seen a lot of applications on like a very wide scale integrated account abstraction as their flagship solutions. Like I said, there's a number of reasons for this. It ultimately comes down to like weighing if at some point the UX benefits of account abstraction through the means of maybe these like branching off solutions outweigh the negative benefits, or sorry, like the negative downsides of integrating it, which there will always be some as long as ERC 437 exists. At some point, that might be gone, but ERC 437 has a lot of inherent downsides to it. So really, there just needs to be for developers this calculation of like, will the UX benefit from me introducing account abstraction either directly or through the means of some other solution? Will this be greater than the downsides that it brings? If yes, then they'll integrate it. I think for a lot of developers, that equation hasn't been super clear because just the benefits are, like I said, a little bit too generalized. A lot of them, maybe it's not just not strong enough for them to feel the need to spend the time integrating it and kind of have some of the drawbacks of, for example, needing to deploy accounts, needing to fund new accounts and stuff like this. So the tooling's there. We just kind of need these use cases and these kind of larger solutions built on top of account abstraction to kind of encourage developers and incentivize developers to go ahead and actually use it within their applications. And that's where we're going to see a lot of the adoption, at least hopefully, of course. It's all kind of theoretical.
For me, as an Unchained user, I think one of the reasons that, on my perspective, that we haven't seen yet the adoption is that we know that the UX that we have is really, really bad compared to what we have in Web 2, and this will not allow us to have, the 1 billion users that we are looking for. But the users that are currently on Chain, then maybe, although it's very suboptimal, but they are used to, this kind of doing a lot of approvals and all of these things that are that account abstraction is solving, but now they have found other ways that they're used to, and hence there is no high pressure from users to devs to, hey, I really want to have this bundling solution, and I really want to have this social recovery, because there are some other multi-sigs, etc., solutions that exist, and those who we want to onboard are not yet there to put that pressure. So maybe there is, maybe I think with the adoption, general adoption that will come with the upcoming bull markets, we will see more demand for such services. But that also, on my perspective, might be one of the points. at least for me as an on-chain user. Let's talk about one of the very trendy words in recent conferences about account abstraction, and this is intent. um, there are a lot of different definitions and takes on intent. Can you, on your own way, define what is intent and how it relates to account abstraction and what it means?
Yeah, so we've spent a lot of time at Particle kind of like exploring the intents vertical, doing a lot of research with intents. We've run a lot of events that are kind of centered around intents because really like I guess like the way to kind of describe it that's so that it's easy to understand is like in Web3, really can break down user experience into like two individual components, right? So on one side, like the first half of user experience, you have the onboarding experience. So how does a user get into Web3? What account are they onboarded into? How flexible is that account? So it's the onboarding process in Web3 today has been made significantly better. Maybe it's a little bit of a stretch to say it's been completely solved, but it is a very simple process now. In a lot of applications, you can go through social logins. 2 clicks, you're into ideally a smart account, an account abstraction wallet. That's super flexible, stuff like that. So like we have the solutions there. But then the second half of the problem, which is actually a more challenging problem, is the interaction. So you have onboarding and then you have the interaction. So how does the user interact with Web3? How do they interact with your protocol? How do they interact across protocols, across chains? This is a much more complicated issue because it isn't as easy as just saying, oh, we'll do social logins or we'll do account abstraction. Because this is a multifaceted issue, right? Interacting with Web3 is complicated today. Users need to not only understand the dynamics of like blockchain transactions, they need to understand like in some way how they work. I mean, when we're doing transactions, these are usually quite raw forms of like ledger entries on chain. I mean, even today, it's like the way we haven't really abstracted a lot of this away. It's still very low level in a lot of cases. And like users, for example, as a user, if I want to go and move funds from one chain to another, if I want to like do a complex series of transactions across multiple applications, or I want to like earn a yield somewhere and like earn yield somewhere else, I mean, like I have to go not only like understand this fundamentally, but I have to go discover every transaction in kind of this list of transactions I need to do to achieve that goal. Sometimes this is 4 or 5 transactions I need to go and figure out how to do, and then I need to manually execute that. So I need to go do the transaction, sign for the transaction, wait for it to go through, pay the gas fee, go through the next one, and so on. And I do this all myself. And like not only, you know, actually manually do the labor of it, but I need to figure out how to do all this. Like this is a lot to ask people. And like the fact that like we think that this process will be suitable for like a billion users, it's going to be very difficult to like have enough education to where people are going to feel comfortable doing that. And like, there's not going to be a lot of issues in terms of people misunderstanding and whatnot, because it is a complicated technology. And most people that are in it today, they're in it because, they understand at least fundamentally how it all works, and they understand the dynamics of Web3. So then the idea is that, well, how do we, we understand how to onboard people into Web3 relatively easily. So how do we have people actually use Web3, within one protocol or within multiple protocols or across chains? How do we have them use Web3 in a way that feels natural to them and that they don't need to worry about the underlying complexity? And like you can abstract away the transactional experience, right? Transaction abstraction is what some people will refer to. And like intents are a great way to solve this. So basically, the easiest way to kind of understand intents is that it'll kind of automatically discover and execute the transactions that a given user needs to do to achieve a goal. So typically, a user would be responsible for discovering and executing transactions to get from point A to their desired point B. Intents will basically say, well, just tell us what your desired point B is, and we'll figure out what you need to do to get to that point, and we'll just execute it for you. You just tell us that you're okay with these transactions being executed. So as a user, if I say, well, I have 100 USDC, I want to go earn yield on this application on Polygon. My funds are on Ethereum, so like what do I need to do? I mean, traditionally, this process would be very complicated. So rather an intent protocol or like a generalized intent protocol, and like you mentioned, intents are it's a very wide scope. So some people would say it's a more narrow definition. But for like a generalized intent protocol, I would say, okay, well, we know that you want to earn a yield in this protocol. We know that you want to do this, like execute this function on this contract. You have your balance here. What needs to happen to get from your current point A to your desired point B, which is the execution of this ultimate transaction and interaction with this contract. So then you execute that transaction, and then the intent protocol says, okay, well, we're going to execute all the transactions that need to happen to get to that point, and then your goal is achieved. So for the end user, it's as simply as they're expressing their goal, they're signing the kind of the intent, and then it's being done for them. And this can even be dumbed down into like more simple tasks like limit orders or like things that are kind of automated where like you have some sort of condition, you have some sort of goal that you want to achieve, and the execution, the kind of like transactions that need to happen for that goal you might not want to manually define this. So you use an intent to kind of go ahead and execute that. Like Brink Trade is a great example of like a kind of an intents that go along those lines, limit orders, automation, stuff like that, especially within DeFi. We at Particle usually see intents as a little bit more, at least like within what we're building, as being more generalized. So kind of like actually transitioning from a more transaction centric landscape where users are kind of like conducting all transactions manually and discovering transactions manually, and making a transition from that over to intent centric landscape. So basically, they're just simply defining goals that they have and things that they want to do, and then everything that needs to happen to get to that point is being discovered and executed for them by solvers and a lot of cool kind of infrastructure. So this is kind of the idea behind intents, and it really is aimed at solving the interaction problem. Whereas like you can imagine a user onboards through Google or Twitter or into a smart account, something like that, then they start using some sort of intent protocol. And as a user, I don't really know like what's happening on the blockchain. I'm just like using an application. I'm using multiple applications, and it's as simple as just me clicking confirm, and it's being done for me. So this is really the future, at least what we believe of a lot of transactions. And we are now getting to the point where like we are building intents on the side, but we're trying to kind of tie this concept, this idea of kind of transaction abstraction in with interoperability and a few other cool things. But we do believe that like this vertical of intents and of like just ultimately simplifying transactions and simplifying the interaction piece of Web3 is one of the kind of key components that are needed to move Web3 into this, again, like this idea of mass adoption of being consumer ready.
We talked about account abstractions and intents and the UX problems that we have. I see currently another big problem that we have, which is with the rollups, and data availability layers and scaling solutions of Ethereum, but not only Ethereum, different chains. We are seeing actually an increasing number of different chains, layer ones, layer twos, etc. And this creates a lot of fragmentation of liquidity. Of okay, how do I move from this chain to this chain? Oh, actually, I don't have the gas, native gas of that chain. So how do I do that? So that's a new problem, which is not directly related to maybe account abstraction. And this is where the term chain abstraction comes into place. And I believe with the new version of Particle, this is something that you're also addressing. So just to give an example, I have like, I don't know, on my Chrome, I have like dozens of wallets. I have like Rabi for EVM chains, and then I have Phantom for Solana, and then I have OKX for Bitcoin, etc. And it becomes harder and harder to manage all of these. You have your wallets, you have your assets, etc. So what is the idea of chain abstraction? And what's the this is kind of, I would say, a newer term compared to account abstraction. So what is the status of that? Particle is not the only one working on that, but is one of the main, I think, topics of the V2. So can you elaborate a bit on chain abstraction?
Sure. Yeah. I think kind of the example that you opened with, or kind of that scenario of like, the growth of L2s and rollups is a kind of great way to contextualize this because, in Web3, this has always been a problem, but it's been a bigger problem now where it's like, now that you have like thousands of rollups and layer twos, cheap scaling solutions that are being launched, which I don't think is a bad thing, to be clear. I think that like we've found a good way to scale and like create application specific rollups and app chain. I mean, like these are solid ways to kind of escape the difficulties of like monolithic design and kind of dive into this idea of modularity and stuff like this. I mean, there's clear benefits to this. I think that this is a long-term mechanism or kind of philosophy of scaling. It's like application specific rollups. I like this idea a lot. But as a result of this direction of like launching, thousands of rollups, thousands of layer twos, and or at least like that's a goal, right? Um, like you mentioned, fragmentation, especially in terms of user experience and liquidity, is a significant issue because now, like multi-chain was already a problem, but now users need to figure out how to bridge between hundreds of rollups for every application using a different chain. Go find a bridge to get funds between chain A and chain B to use a different application. I mean, this is an even worse user experience for most people than it was before. So like, well, then the question becomes like, how do we maintain like what is a true and proven solution to scaling within the EVM ecosystem, but not have the UX trade-offs of the fragmentation. So how do you eliminate the fragmentation and then just retain the scalability benefits and give users a method of using these different rollups, using different blockchains in a way that feels seamless for them? So like this is really what chain abstraction aims to address. It aims to abstract away the complexities that are commonly associated with multi-chain interaction, of which there are many, right? So like just the process of like going and finding a bridge and executing the bridge. Sometimes it's slow, it's difficult, sometimes it's unsafe. I mean, there's a lot of issues that are kind of involved with doing this, and it's just a long process. So now that we have all these different chains, doing like applying this process to every time you go between a chain, it's just pretty. It's a lot to ask of end users. So chain abstraction says, well, okay, we recognize this issue. How do we create an environment where users ideally don't really know what chain they're using, or they don't need to know what chain they're using? It's not kind of a piece of information that's required for them. They don't need to necessarily think about where they have their balances, because this movement between chains and the actual concept of like cross-chain interaction is handled on an infrastructure level, not on a user level. And this is how it should be, right? So basically, like as end users, the vision here is that they'll onboard to an application. They'll have some level of balance. They'll deposit balance into the application, USDC, or their native token, or whatever that may be. Then they go to another application on a different chain, and rather than having to like bridge and like manage all these different cross chain balances, what they can do now is just simply start using the application on the other chain, and that's it, right? And then what needs to happen is basically that, well, then whoever they're using, the kind of chain abstraction solution that they're using, would then need to basically move those funds from their original chain, like the source chain, over to the destination chain, which is what they're using in the kind of the second application, to then, of course, allow them to do transactions. So this is basically like, at least what we're building is like a mechanism that we call universal accounts. And maybe we can kind of talk really deep more about the specifics in a moment. But basically, universal accounts are like at a high level. They're actually ERC 457 smart account implementations that are tied and powered by our modular layer one blockchain that we're going to be launching very soon. This blockchain is just very simply responsible for coordination and kind of storing these smart accounts. So maintaining source of truth, source of state for these smart accounts, and then coordinating cross-chain transactions to enable this idea of basically allowing users to have one balance for every blockchain. This is ultimately the goal with universal accounts. It's like one unified balance for every chain that you're using, so that if I'm moving from chain A to chain B, I don't need to think about bridging, because for me, it feels like it's one balance as if it was a monolithic chain, right? So it's like, as a user, it feels like I'm using one blockchain for everything. So like this is like ultimately. Exactly, yeah. Even across VMs, so into like Solana, even into Bitcoin, into the Cosmos ecosystem. So it feels like everything's unified under one layer. And really, this layer is kind of universal accounts, of course, powered by this L1. So this kind of creates an experience where like users, you can kind of start hopefully seeing this vision now, where like you onboard social logins into a smart account. The smart account is a universal account. Now you can go and interact across applications. You have no idea what chain these applications are on. You're just using them as you would naturally. You don't need to worry about moving your funds across chains. It's totally removed from the end users or just using the applications. And this is when you start getting this user experience where like it's very Web 2 like. Now you even want to tie in like intent-centric design, and now you can get rid of like the actual transactional complexities of like interacting with these protocols in the first place, plus the removal of like the multi-chain complexity. And now like this is where you start to get like true abstraction. So like at Particle, we usually kind of categorize it as like liquidity abstraction, wallet abstraction, gas abstraction. Just like we're trying to like remove a lot of the raw parts of blockchain that make it difficult to use, and kind of give users an experience that feels as like high level, as easy to use as possible, while of course staying decentralized, being scalable as an ecosystem. And like this is doable. So like chain abstraction is really one of the next big steps to get to that point. And it is in a large capacity, at least for us, a branch off of account abstraction, because like, for example, our solution, while it is powered by our layer one blockchain, at the end of the day, it's a smart account implementation that kind of again like allows for this universal balance, for this one balance across chains, in which we're basically just coordinating transactions between these different chains to create this perception of one balance. So it's a quite an interesting model. We just announced this kind of like new direction. Kind of, it was more so like a culmination or like an evolution of our product stack. We announced this just earlier this week. The response has been great. We found that it was clear that like this is a solution that people want. This has been one of the longest standing problems with Web3, especially now that we're getting into like this hyper scaling era with all these layer twos and these different rollups. A solution like this is absolutely required. And like you mentioned, it's not only us that's kind of building towards this idea as well. The Near Foundation, they've been doing a lot of fantastic work in chain abstraction. You even have Frontier Research now, which built this group called It's called the Cake Group. It's basically like a research group built around like the acquisition of chain abstraction. And there's a lot of amazing folks that are going in there and that are contributing to this idea of chain abstraction. So like this is a coordinated effort across the ecosystem in terms of kind of getting to this point where, like what I mentioned, this multi-chain, this complexity and like what we typically would associate with multi-chain interaction is largely abstracted away. So this is kind of the idea and what we're building towards now, and we're trying to kind of collectivize our tech stack towards this goal so that we can kind of achieve this holistic vision of like truly next gen UX that is capable of kind of serving a significant number of users.
Amazing. As an on-chain user, I can attest that I truly believe that this is one of the biggest pains that users have on chain. So now with the introduction of account abstraction as well as chain abstraction, I think we are in a good position to start talking more specifically about particle. You mentioned about again the universal, abstraction, and you have this element which is called universal gas. So someone can purchase a token on Lina, L2, but they don't have the, maybe they don't have the native token, so they can use actually the ETH that they have on Arbitrum, and then do it in one click and then do whatever they want. How does it work behind the scenes, technically speaking? Is it like there are some data transfers, I would guess. Can we think about this just bunch of APIs calling each other when you want to do this intent specifics? Can you elaborate on the technicalities on what happens behind the scenes?
For sure, yeah. So, like the big goal here was like, how do we create an experience where a user feels like their balance is akin to if I just had one balance on Ethereum and I just interacted with applications on Ethereum. And within that experience, it's great because you have one balance and you're not worried about bridging or anything like that. You're just using the applications. So we want to create that same philosophy of like a unified balance and apply it to every chain and create this kind of perception of, like you can pay for gas fees with any token that you want to use. Doesn't matter what chain it's on. You can do transaction on any chain. Doesn't matter where your balance is at. And the way that we're doing this, right? Because like it's not necessarily possible to have like the exact same balance on every chain. So like, how do we create this idea or this perception of like a unified balance? So in large part, infrastructurally, this is driven by our layer one blockchain. Now this layer one kind of serves two different goals. One of which is actually kind of the storage of these universal accounts. So one big major challenge with smart accounts is that if you deploy it on one chain, then deploy it on another chain, and then on one chain, let's say I update the owner of the smart account or I insert a module or something that changes the state of that contract. This is now basically like different on the different chains that I have. So the account isn't constant across every chain, which means there's a lot of fragmentation. So one of like the more boring use cases of the chain that like isn't directly relevant here, but one of the main use cases for the chain is to act as like a storage layer for these smart accounts and to facilitate like updates across chains and make sure that they can stay constant. This is going to be solving a very large issue with smart accounts. But the more interesting component of it is actually the coordination of cross-chain transactions. So basically, whenever you submit a transaction on a given application, right, I onboard to the application with my universal account. Let's say I have, I don't know, $100 in ETH on Base, and I'm using an application on Arbitrum, right? On the application on Arbitrum, the transaction that I'm doing costs $50 in ETH, right? So then what we can do is to say, okay, well, we understand like what needs to happen here. The user basically submits a specialized user operation, which is like a specialized transaction, to what we call our decentralized bundler. This decentralized bundler exists on our layer one, that we can basically figure out what transactions need to happen to get, in this example, their funds from Base to their funds from Arbitrum in a way that's as fast and as secure as possible so that it feels instant for them and that it creates this kind of illusion of a unified balance, because it is very simply just very fast movements of balances across different chains to where it's like, I'm doing a transaction here, pulling balances from another chain that I'm doing a transaction on, we're pulling balances from that chain. And it's just a continual moval of value, right? Based upon the transaction that I'm doing and the chain that I'm doing it on. So for us, we're just discovering what transaction need to happen for a given like in this case, you can think of an NFT purchase or you're staking or something like that on Arbitrum in this example. So to do that, we need to basically figure out. In this example, it'd be like one transaction ultimately. It would just be a bridge of ETH from Base to Arbitrum. We're going to be using a few different components for that. So we're going to be using Hyperlane for kind of faster, more high volume transactions. Then we're also going to be using layer 0 for more security focused transactions, where for each of these, we're going to be implementing basically different infrastructural components that will be geared towards different categories of transactions to make sure that they are as fast as possible or kind of just as efficient as they can be in their context. We're also going to be using like Across, which is a fantastic protocol for some EVM transactions. Then additionally, for like interaction between the Cosmos ecosystem, for example, we're using IBC. And we're basically just like culminating a few different components that will all work towards facilitating cross-chain transactions that our layer one that we're deploying is going to be kind of coordinating and like kicking off essentially. They'll be relaying these transactions to these different messaging components, Hyperlane, layer 0, etc. Then from there, it's going to execute a transaction that then ultimately, kind of in this case, satisfies the constraints for a given transaction that they're doing on the destination chain. So this is Arbitrum. So for the end user, like all that said, the end user, they're going to Arbitrum, they have their balance on base, they do the transaction on Arbitrum, and that's it. In the backend, we're pulling that value from base, using it on Arbitrum, and like we're doing all these like fancy transactions in the backend through the means of the layer one and through these messaging protocols. But for the user, it's like just a few seconds of added processing, and for them, it feels totally seamless. They didn't need to think about it at all. It feels like they have one balance for every chain. So this is kind of like at a high level what we're doing here and how we're actually handling this movement of value in the backend. Like I said, very simply, just can be understood as the very fast atomic movement of funds based upon a given transaction and what you need in terms of value from that transaction, as opposed to where your balance is across different chains and moving value accordingly to meet the conditions of that transaction. So hopefully, without getting too technical, that kind of provides an overview of actually what happens whenever you use a universal account.
So does the end user need to specifically say, I want my funds from base to move to Arbitrum to be able to do this transaction? Or they just need to say, I want to buy this $100 thing on Arbitrum, and then you would take care of where the funds would come from?
Exactly. Yeah. So that second scenario where basically like, they just simply do the transactions they want to do. And then we handle everything on the back end. Where are their funds? How do we pull their funds? What's the best way? What's the cheapest way to get their funds over to this destination? Because for the end user, ideally they won't necessarily be concerned or they won't necessarily even really know where their funds are in terms of on like the specific chain. So they won't know if it's on Arbitrum, if it's on base. They're just doing the transactions and we're basically figuring out what's the most efficient way to get this value that they need for this transaction from other balances that they have across chains to then meet this condition, right? And for the end user, it's all presented to them in a way where it's just they have their list of balances, right? They know what they have, and it's just like an aggregation of all their balances across chains. So then to actually make that a reality, to make that kind of aggregation real in terms of when they do a transaction, to pull those balances, we're just kind of coordinating all of that ourselves. And the end user, they're just clicking confirm on whatever they want to do on the NFT purchase or their staking transaction. And then we're, basically funding that transaction for them through the means of their balances on other chains.
That's super interesting. So, is there some machine learning involved here? Because I guess if I have if I want to do a transaction on Arbitrum and I have some funds on Base, on Optimism, on Polygon, and so there are different possibilities, right? You can, convert them to ETH, and you can, and you can maybe you have to study what are the cheapest gas fees, and so there might be at some point you want to take one action, but there are different ways of achieving it. So are you using some kind of machine learning there to optimize that? Just curious about that.
At the moment, we're mostly thinking about like you could even like kind of use like a solver architecture where it could very simply just be like a computation of like what is the most efficient path. So like this is where you start getting into almost like the intents idea, where it's like we basically need to figure out like what's the best path from point A in this case to point B, which is just getting funds from either one chain or multiple chains over to this destination chain. What's the cheapest way? What's the fastest way for the end user? Because with cross chain bridging, it's very volatile between chains. So base to Arbitrum will be one speed, one cost, and it'll be totally different for another combination of chains. So it's just a matter of like, how can we make this as easy and as cheap as possible for the end user? So we can kind of figure this out computationally. We're going to have a few different infrastructure components that we'll kind of have as a part of the chain, both on-chain and off-chain infrastructure that will contribute towards like figuring out what this best path is, and then of course executing that. So this is definitely quite an important component because, like you mentioned, your scenario, let's say in this, kind of going back to the what I was mentioning a moment ago, where I want to do this transaction Arbitrum. Let's say actually I have $100 on Base, Polygon, Optimism, and Ethereum, right? So it's like, well, we don't want to pull the money from Ethereum because that's going to be expensive, it's going to be slow. So like, is it going to be cheaper on Optimism? Is it going to be cheaper on Base? Basically, we need to figure out like what's the best path here, and then we can go and execute that. If all they have is funds on Ethereum, then we can do that. But it's just ultimately about what is easiest for the end user and how can we optimize it at every step of the way to make it feel as seamless as possible, as if they were just doing transactions all on one chain.
And if I understand correctly, the reason that you need an L1 in the particular L1 is that you need a database to store the state of all the balances of all the different you know chain balances that a wallet has on different chains. You need to store that in one place so that okay, this is the action that the wallet wants to make, and okay, what are the possibilities, and then you can evaluate the state within the data that is within your blockchain. Is that the purpose of the blockchain?
Yeah, so the blockchain does do a lot of kind of storage for these smart accounts, mostly in like the actual underlying state of the smart account. So you can imagine like the owner of the smart account or the modules that are attached to the smart account or anything of that nature. So we do track state very closely, and we basically like store state for every smart account as like a single source of truth for every chain, so that you can like reference that and make sure that smart accounts are kind of like in line with each other and whatnot. So that's of course one major component of like why a chain exists as like this sort of storage layer. It's existing exclusively to like track these different smart accounts in terms of like what state are they on this chain, what's state on this chain, like what's the true state that they should be. Then of course the coordination of transactions is a big component of like the point of this blockchain. So we usually consider the blockchain as like almost like a universal settlement layer, almost where it's like going to be the main facilitator of these transactions, because whenever you submit a given transaction, it'll go through the blockchain first. That'll basically, at that point, we'll figure out what transaction need to happen. Then through that, we can then kind of relay these transactions to those different providers like Hyperlane, Layer Zero, etc., which will then ultimately be executed on like the destination chain that you want. So this is kind of the idea behind the chain in terms of it'll play a very crucial role in coordinating transactions and an equally crucial role in maintaining smart account state and kind of coordinating the synchronization of smart account state across different chains.
So we mentioned in the smart account state that involves a lot of data. You have actually one of the components that you have is the aggregated DA, data availability layer, where you're working with Celeste, EigenDA, Avail, and Near DA. First question is, are you using these DAs to store your data? Second question is, why is the need for an aggregated DA? Because some different protocols choose one specific DA. What is the advantage of using a bunch of them?
Yeah, this is a really good question. So we take a very modular approach to our layer one in terms of, our layer one has a very specific purpose. It's not going to be used for applications to deploy on. It's going to be used purely for like what I mentioned, which is the coordination and the storage of these smart accounts. So then like, how do we make that as efficient as possible? And how do we, again, at every step of the way, reduce costs for end users and be as reliable as possible? This is where like modularized blockchain design in terms of like, in our case, outsourcing DA becomes a very viable solution. So we did think about originally, maybe we just want to use one DA layer. In this case, we can reduce costs, we can be more efficient, we can be more secure, we can reduce overhead, stuff like that. That's great. We could use just one, but we felt like the responsibility that comes with coordinating and like needing to basically be like the main infrastructure component that will exist to facilitate cross-chain transactions across ideally millions of different wallets is quite high. That's a big responsibility, right? So we need to make sure that the chain is as like reliable and stable as absolutely possible and as efficient as possible. This is where you get into the idea of aggregated DA. Now, we aren't the first organization to come up with this idea. There's a lot of really great developers that have kind of built proof of concepts and things that have like followed the same philosophy, mostly for like two reasons. One of which is reduced dependency on a single vendor, so there's no vendor lock-in. For example, if one vendor goes unavailable or something happens where you want to switch vendors, then you can do so very, very easily and you don't lose any service time at all. So you like increase stability and reliability significantly by using multiple DA layers. In our case, we're using a few different ones. We're using Celestia, Avail, EigenDA, and NearDA, all of which are fantastic solutions. They each have their unique benefits. They're great in their own ways. We don't see one DA as being like the winner of everything. We believe that each of them have unique offerings, and we want to leverage all of them independently. So some transactions will use Celestia, some transactions will use Avail, and so on. And this is quite important for us. not only for the reliability piece and being sure that we don't have that vendor lock-in, but also for efficiency. You can imagine that different DA layers, I mean, they're going to cost different amounts to store different amounts of data. So we need to make sure that, for every block that we're doing, what can we do to be the most efficient? What data layer is going to be the cheapest? This isn't always a straightforward question. It'll, sometimes even be quite volatile. So we basically are going to be using the underlying D layers as a way to increase efficiency, choose what's most efficient for a given time or a given block. Then also, of course, increase stability and reliability through the means of reduced vendor lock-in and kind of being able to balance across multiple providers and have lots of fallbacks in the case that we need to wean off of one, or if one goes down or something of that nature. Any scenarios which can be sometimes seen as like edge case scenarios, things that don't happen very often. But for us, because of the responsibility here, it's really important that we account for that and that we have like a system that's as efficient as possible and that's as reliable and secure as possible.
Let's talk about the competition landscape. There is like two major solutions that I can think of that I'm aware of that are also going on that direction. One of them you mentioned is Near, which is actually where I first heard the term chain abstraction. It was by Near, and so you're collaborating in the DA side with Near because they also have a data availability solution. But I guess here on the chain abstraction, they might be a competitor. And then the other one is Polygon. As you know, they've recently launched this Polygon aggregation layer, and Sandeep is now very bullish on this and is talking a lot about this. So can you tell us how, like, how are these solutions different? Are there any kind of different niches that they're addressing?
For sure. Yeah. So Near is, we've had a lot of conversations with Near, Madam out in Denver. What they're building on the chain abstraction side of things is incredible, and they've achieved a lot in that regard. We don't consider Near competitors. Actually, we consider what they're building to, in a lot of cases, be pretty synonymous or like compatible with what we're building to some capacity. We're big fans of their solutions, and we think that like they've done a great job of kind of like pioneering this term of chain abstraction and like carving out this vertical. So we're very close with their team, and we are big fans of what they're building. And they host these chain abstraction day events in person. We're going to be sponsoring the next big chain abstraction day event that they're running out in Seoul. I'm actually flying out there in like 3 days to go to that event. So they do a killer job kind of rallying the community around this idea. And I think the big goal with chain abstraction in a lot of capacity is actually to ultimately come up to like these different organizations, us, Near, and so on, are all building solutions that are ultimately all addressing the same problems. Like how do we kind of like use the different types of like different components of the solution that we've all built independently and create like standards for it. So like this is where you see like Frontier Research's their cake group or their cake working group, which is just simply like a philosophy for achieving chain abstraction, and it involves a bunch of different industry leaders. This is where like that group, which is dedicated towards like outlining standards and methods of achieving chain abstraction in a way that isn't exclusive to one provider, we're very on board with this, and we believe that we can work with Near, we can work with any other organization that's kind of aligning themselves with this vertical to ultimately like as an ecosystem work towards like a single layer, a single standard that our technology is compatible with, that Near's technology is compatible with, that creates like this like ultimate experience for end users where they have the benefits of all these different technologies. There's a standard that we can abide by, and like this is kind of the most decentralized like Web3 native approach that we're very excited about. There isn't something like this yet, but like I mentioned, we're all working very hard on ultimately trying to come up with kind of like a chain abstraction standard. And this is where like we're working with Near, we're working with multiple other organizations in terms of contributing here, and we're very excited about this possibility. So we don't necessarily consider a lot of these people that associate themselves with chain abstraction as competitors like purely peers that are all building their own solutions, a lot of which are directly compatible with ours. Polygon is slightly different. They're building the Agglayer. They don't usually associate themselves with chain abstraction as a term, although I could probably say like Agglayer is like in theory very similar to chain abstraction. We also like what Agglayer is doing. We think it's a very interesting technology. We've been looking at it for a long time. We think that it's like their design here and their architecture is awesome. I mean, they've clearly spent a lot of time kind of thinking about this and creating something that is really unique. And I'm pumped for like how that'll materialize. Because I mean, for us, anything that can help the industry move forward and kind of like create a better user experience and ultimately achieve like the goal that I was talking about in the beginning is, we're totally on board with it. So I think what Polygon is building, we're definitely quite excited about it. We're pumped to kind of like see how it turns out and see how the adoption goes. For us, we're very focused on the chain abstraction vision, especially in regards to working with these other organizations who are also aligned with chain abstraction, like Near, like Frontier Research, and so on. But definitely what Polygon is building is absolutely a very a smart solution that I'm sure will kind of result in a significant amount of adoption. So we're definitely quite aligned with kind of their philosophy there, and we're excited to see kind of what they build and how it materializes for the.
Yeah, this is a very positive general observation that I've had in talking with different founders and protocols is that everybody is looking for that 1 billion user adoption. And so when we talk about competition within the space, is actually is a very positive sum game, where protocols are collaborating a lot together to ultimately facilitate this onboarding of the mass adoption. There are two, three other components of Particle I would like to talk to, because Particle is actually a very, very ambitious protocol on what you guys are on building on different components. So one, can you elaborate a bit on this element of you have your master smart contract, which is controlling everything, right? Is that the same as your layer one, or is there anything else to it?
Yeah, so this will be kind of a component that exists within our layer one. This will be a very important component of this kind of like synchronization and cross-chain facilitation of like a universal state for smart accounts. So, and like I mentioned, there's this big problem of, whenever I deploy a smart account on Arbitrum, for example, and I update it and I change some part of the state, then I have my smart account on base. Typically, these would be at odds with each other. So what we can do is basically have a single source of truth, like a master smart account that exists on the layer one itself, that we can then kind of use to automatically synchronize with other chains and kind of create this universal state for smart accounts. And this has like been one of the major problems with multi-chain experience when it comes to account abstraction, is purely just the fragmentation between account instances across chains. So we're trying to solve this through the means of kind of acting as a storage layer for these accounts, and the kind of master smart account idea is a big component of that.
Amazing. Another one I would like you to briefly talk about is the dual staking model, which is concerns your design and security. So can you elaborate a bit on that?
Definitely. Yeah. Dual staking is something that I'm personally very excited about. It's kind of some people would consider it kind of a boring thing, but I think it's quite exciting in terms of like, haven't been a lot of protocols that have implemented this idea of dual staking yet. And like, we're excited to be kind of one of the earlier ones, because like dual staking basically refers to the fact of like, whenever you're building a new protocol, specifically a proof of stake protocol, and you're using your own token for it, like bootstrapping the security of a protocol with your own brand new native token that is volatile, that has negative price action, has positive price action. This is something that is not only unhealthy for the token in terms of having negative impacts to the token itself, but also it's not healthy for the protocol, for the chain. It's less secure. You have like this sort of risk of like a death spiral with these tokens. So it's like our thing was like, well, how do we bootstrap security of the network without 100% reliance on our native token, so that we can reduce and even eliminate a lot of these negative benefits, or sorry, negative kind of like attributes that happen whenever you use your native token to bootstrap a proof of stake network. So this is where dual staking comes in and actually plays a significant role in basically solving this problem. Dual staking simply just refers to the security of both our native token and of restaked ETH to validate a network. So we're using Eigenlayer to basically like act as half of the underlying security for our network. We'll have like validators from Eigenlayer that will validate blocks, and we'll have validators from our native token that our native token is delegated to, that will validate. And like basically, they both need to agree on a given block on its validity. If one of them disagrees, then it's an invalid block. This way, we can kind of take crypto economic security from restaked ETH and also reduce reliance on our native token, then kind of create this better consensus model where we're using Eigenlayer and we're using our native token to secure our network.
So actually, dual staking is just another word for restaking. So it's you're just so can we say that your particle network will use the security of Ethereum network through restaking an eigenlayer to secure your network, so you don't have your validators, etc., and you can secure your network. Is that correct?
Yeah, we'll still use our own validators, but only half of it. So basically, like the idea of dual staking is like taking half of our network, securing it by our own validator set, our own native token. Then the other half of it is secured by Agglayer. This means that we still have our own like, kind of like sovereignty and control over the network via our own, of course, participation and consensus. And also, of course, the other half is by Eigenlayer through, of course, restaked ETH. So we're kind of taking the crypto economic security of restaked ETH. We're being able to take advantage of that while also, of course, having the advantage of retaining like the control and kind of the participation of our token within that protocol. So it's a pretty cool model. Actually, Eigenlayer published like a fantastic article about this. Maybe it was 4 or 5 months ago. So if you Google dual staking Eigenlayer, you can probably find it first result. It's really fascinating, and we're going to be implementing that very soon within our protocol once we release kind of like the first major full mainnet version later in Q3. We'll be implementing dual staking as kind of like our mechanism of bootstrapping security.
That's amazing. It's the first project I hear implementing dual staking model, and looking forward to what this will look like. Amazing. So tell us a bit about the roadmap. I mean, we talked about a lot of different components. I guess there is a lot that you guys are working on in the next quarters. So what do you have for the next for 24, 25? What is coming?
Yeah, so we've been kind of pretty heads down over the past few months getting ready for the launch of this layer one and the launch of universal accounts. And we're now at a point where we have a very clear timeline for that. We intentionally waited quite a while to announce anything until we felt like there was a clear, like relatively short term, just the rest of this year timeline for getting everything released. That's why we just only like this week announced the layer one. So we kind of kept it behind closed doors for a long time. And we're now at a point where like we're going to be launching testnet relatively soon. Basically, like ideally very early Q2. Then we will be launching mainnet not too long after that. Also, ideally in Q2. Again, nothing like super confirmed at the moment. But then in Q3 we'll launch like the first like I guess we'll call it like V2 of our mainnet. So we'll have two mainnets, one in Q2. That'll just purely be like our universal accounts and like the core technology here, right? And then in Q3, we'll launch like V2 of our mainnet. That'll include, of course, all the core functionality as well as dual staking and aggregated DA. So that's when we're going to be kind of introducing all these components to like this cohesive layer one with everything that we've been talking about, all published, ready to go. But starting from the testnet here very soon, like just in the next really few weeks or a month, that's when you'll be able to actually start testing out this technology and giving it a try. Then once we do mainnet, of course, and that's like when we'll do like the full release of it. And then once we do mainnet V2, we'll have all like the cool security features and aggregated DA to kind of bootstrap it and make sure that it's as robust as possible. So everything is happening very quickly over here at Particle. We have been focused on shipping very quickly. So we have a lot of cool things planned for the next few weeks. And of course, associated with these launches, we have a lot of very interesting things that we're kind of working on to make sure that we can have a successful launch and we can kind of properly engage with the developer community, with the general community, and really make sure the solution is used and that we get good feedback for it, and that hopefully we like actually use it in a way where it truly does like tangibly contribute to onboarding and hopefully solving a lot of these UX problems. So we're trying to make sure that we can maximize its impact on the space in terms of like purely like you know real material like changes in terms of the adoption of Web3, and we believe that it'll be hopefully quite impactful. So our goal is just making sure that we can get to that point, that we can have as big of an impact as possible, and that we can make sure the technology is ready for that. So that's kind of going to be kicking off with our testnet, and then of course leading into our mainnet as well.
Amazing. So you mentioned that your chain is actually a coordination chain mostly. So there is something that we are not going to see meme coins launch on your chain, right? This is just purely for devs to actually work with your chain.
Yeah, purely coordination, just an infrastructure component. We're not going to have applications on the chain necessarily. You won't see meme coins on our chain. It's just going to be as a mechanism to power universal accounts. So in that way, it's going to be quite neutral. It's not going to be something that we're trying to get like developers to build applications on. More so, a mechanism of facilitating these transactions, of storing these smart accounts, and acting as this like core settlement layer for universal accounts and this idea of chain abstraction.
Amazing, amazing. Looking forward to your testnet and your mainnet launch. We like to finish the interview with a hot take. So I know that you've spent a lot of time on Solana as well as EVMs. I would like to ask your opinion about the future of L1s. We have new layer ones that are more scalable even than Solana, Sui, say, and Aptos. What do you think about the landscape of L1s in few years?
This is a really good question. I'm a big fan of the Solana ecosystem. I think actually I'm wearing a Solana shirt at the moment, and I the, I'm maybe a little bit biased. I do like, to be honest though. I think in terms of scaling, I definitely do agree with like the modular thesis a little bit more than monolithic. I think that like the idea behind EVM in terms of scaling via different rollups via modular like modular blockchain design. I mean, it's clear that like this has worked for a number of different blockchains, a number of different applications, and I do believe this is a more long-term scalable approach to a scaling blockchain, especially if we can tie in chain abstraction. I think that at that point we'll have an ecosystem that is really ready for consumers. I do think that like just purely by the nature of monolithic design, there are limitations. I think Solana is definitely one of the chains that has done a very good job of scaling quite effectively. They've been having some issues recently. I know there's been a kind of a war between Solana and like the modular guys on Twitter pretty recently. I haven't been participating, but I do think that there's a debate to be had there in terms of like how like viable long term is monolithic design versus like a more modular open ecosystem with like thousands of rollups versus like one core chain hosting every application. I think it's like I don't really think it's super cut and dry. I think Solana has a lot of cool things happening, like Fire Dancer, for example, that will make it a much more efficient chain. I mean, gas fees will go to like Fire Dancer is an incredible technology. So like this is a big thing that Solana is doing, and a number of other things that they're doing to make it more efficient. And Solana's not the only one. There's a lot of layer ones that are launching that are very efficient, they're very fast, they're scalable. I think personally, if I had to bet, I would probably say that most chains will go the route of kind of in some way or another encouraging kind of modular layer two or like layers on top of the chain itself. So like I think it was I don't know how to pronounce it. It was the founder of a Drip House. He posted on Twitter recently and has been quite viral that he wants layer twos and rollups on Solana. And of course, this was quite a controversial take. So yeah, I think like to be honest, I think that scaling solutions that build on top of like already scalable layer ones, especially to get past the limitations of monolithic design, I don't see this as being unrealistic. I think that ultimately if we want to get to a billion users, it is really hard to do that in like the design of a single system. So I'm a big proponent of kind of the way that the Ethereum ecosystem is going at the moment, and like for example, like how Celestia has been leading and like the narrative that they've been driving has been quite strong, and I do agree with that fundamentally. And I think that as an ecosystem, we'll get to like a point where like people will agree on like what works best, and I'm sure there's going to be some sort of winner or some best balance of like a super efficient layer one with like even more efficient layer twos on top of it. They're designed modularly. I mean, you can kind of get into the specifics there, but yeah, I think that it's quite an interesting landscape at the moment to watch. Like, I think to be honest, it's healthy discourse because these are really pressing issues that will ultimately like change the course of how we approach Web3 and how we scale Web3. So, from my point of view, from somebody that isn't necessarily like working on that on like the scaling problem directly, but rather trying to solve the UX surrounding it. I think it's been quite interesting to watch, and I'm excited to see kind of how over the next few years we continue to kind of settle into ourselves in the industry and figure out like what works best here, and ultimately solve a lot of the issues that have kind of been plaguing Web3 for the past really for its whole lifetime.
Amazing. Thanks a lot, Ethan, for this conversation. You shared a lot of very interesting insights. And so thanks a lot. And hopefully we talk soon about again with when you launch Particle.
Absolutely, thank you so much for having me. Great questions. Was pumped to be here, and yeah, I think there's a lot of cool topics here, and I'm excited to kind of continue diving in as we launch some cool stuff over the next few months.